This is the Math 227 Statistics. Today we talk about Chapter 3. Chapter 3 title is Data Description. Chapter 3 Data Description. First, we talk about empirical rule. Empirical rule. What is the empirical rule? It's we draw a horizontal line, then we draw a center. In the center to the left, to the right is a symmetric. And this we call bell shaped. Symmetric to the center. In the center is the mean. Mean we use population mean. We use mu represent this population mean. And the standard deviation we use sigma represent. If this is a sigma is a standard deviation. To the right, one standard deviation is a mean add sigma. Mean add 2 sigma. Mean add 3. 1, 2, 3. Mean add 3 sigma. 3 standard deviation. And to the left, those are equal. Minus 1 standard deviation and equal length minus 2 standard deviation, and to the left mean minus 3 standard deviation. And the under the curve total it's 100%. The area under the curve it's 1 is 100%. Then the mean away from mean 1 standard deviation away from mean. 1 standard deviation is 1 standard deviation above the mean and 1 standard deviation below the mean. This area is 68%. 1 standard deviation above the mean is total is 68%. This area, 68%, which is from here to here, this area under the curve, 68%. And 2 standard deviation from above the mean. Above the mean, 2 standard deviation, and below the mean, 2 standard deviation. Under the curve, this area, 2 standard deviation under the curve. It's 95%. This 95% under the curve, this area is 95%. And the 3 standard deviation from the mean, 1, 2, 3. 3 standard deviation above the mean, and 3 from the mean 1, 2, 3. Three standard deviation below the mean. Under the curve, this area. And that's totally, it's this area. It's 99.7%. And this we call empirical rule. Empirical rule here. And also called 68, 95, 99.7 rule. So, according this rule, empirical rule, suppose a data set is normally distributed, is symmetric to the center, we call bell-shaped, it's normally distributed, with a mean we use mu represent, of 100. So mu equal 100, mean equal 100. Standard deviation is 10. Standard deviation with sigma represent. Standard deviation sigma equal 10. Approximately what percentage of data will fall between 90 and 101? So mean is 100. Below the mean, 100 minus 1 standard deviation is 90. Above the mean, 100 add 10 is 110, is a mean add 10, is a mean add 1 standard deviation above the mean. 90 is mean 100 minus 10 is mean minus 1 standard deviation. So this asks you what's the probability. 1 standard deviation above the mean, from 90 to 110. Mean is 100. Below the mean, 1 standard deviation is 90. Above the mean, 1 standard deviation is 110. So it's from 90 to 100 is 1 standard deviation above the mean is this area. So this question, the answer is 68%. If I ask you, what is the probability between 80 to 120? 80 is 100 minus 2 times standard deviation 10. 120 is 100 add 2 times standard deviation 10. So it's 2 standard deviation above the mean. That it's 95%. Answer is 95%. Second question. The numbers of hours spent on studying are recorded from a high school student console. Consider these values as the population data. That's given here, population data. As a population data. Consider those are population. Show all your work as needed in the space below for the following. First one, find the mean, median, and the mode, and the mid-range. First of all, we order the data, put them in order. So the 3 is the smallest one. Then next is a 5. Then next 6. Then next 7. Then 8. There's another 8. Then next 9. Then 11 and 12. And put them in ascending order first. Then mean. The mean formula is summation of x. What is x? X is variable. Variable represented each of those data. This sigma, this is a summation, sum, total, sum, summation, divided by n, how many data, which is also called average. Mean actually is average. Average. It's the sum of the data. So you add together 3, add 5, add 6, add 7, add 8, add 9, add 11, add 12. And you can use calculator, add those data, get the sum is 69. Then divided by how many data? 1, 2, 3, 4, 5, 6, 7, 8, 9. So divided by n. N is total 9 data. N is 9. Divided. Use calculator. You got 7.666 repeating 6. Rounded and round to one more decimal digits than the original data. The original data is a whole number, one more digits. So it's to the 1 digits. So round to 1 decimal digits. Since round to this 1 more decimal digits. Since to the right, 1 digit is 6 more than 5. So you round up, get 7.7. That's the mean. Then what is the median? Median is the middle one. Total 9 data, 9 divided by 2. You got 4.5. So middle one should be the 5th data. From left, counted 1, 2, 3, 4, 5. From right, count 1, 2, 3, 4, 5. So this median is 8. Mode is the most frequency one. So only 1 3, only 1 5, only 1 6, only 1 number 7. There's 2 number 8. And the 1 number 9, 1 number 11, 1 number 12. So most frequency is 2. So the mode is 8. The others only happen once. Only 8 happen twice. Frequency is 2. Is the highest one. Is mode. So mode is 8. Mid-range. Mid-range is midpoint. Mid-range is the minimum. Minimum is 3. Maximum is 12. Mid-range is the minimum. Add maximum divided by 2. Minimum is 3. Maximum is 12. Add together is 15 divided by 2 is 7.5. That's what we call mid-range. Now, I add in one more. That's we learned in chapter 2. What is range? Range is maximum minus minimum. Range is from 3 to 12. So it's 12 minus 3. It's 9. It's a range. Mid-range is midpoint. Midpoint. So it's right in the middle point. If you do 3 add 12 divided by 2 is 7.5. It's over here between 7 and 8. This midpoint is a mid-range, also mid-range. So this is a mean formula, the summation of the data divided by how many, the number of the data. Formula is the summation of x over n. Here, formula. This is a formula. This is the mean formula. Summation of x over n. That's mean formula. That's the first formula we learn. Next, we are going to learn this formula. This formula is what we call variance formula. Variance is a summation of x minus mean quantity squared divided by n. That's a formula for variance. Standard deviation is the variance. After you get variance is here. This is a variance. Take square root is we call standard deviation. So next example, find the variance and the standard deviation. Variance is formula is sigma squared equal summation of quantity of x minus mean squared divided by n. What's this means? Means first number is 3 minus mean. Use exact number 69 over 9. Don't use after rounding. After rounding is approximate number. So use actually number is exact number fraction 69 over 9. Quantity squared plus next number 5 minus mean 69 over 9 quantity squared. Add next number 6. 6 minus mean 69 over 9 quantity squared. Add next number 7 minus mean 69 over 9 quantity squared. Add, continue 8, 9, 11 until last one 12 minus 69 over 9 quantity squared. Then divided by total 9. And use calculator. You can figure out the top, the numerator is 64 divided by 9. 64 divided by 9, use calculator, get 7.11111, repeating. And round it to 1 decimal digits. Since 1 is less than 5, so after truncate, get 7.1. That's the variance. Variance, take square root. Variance is use exact number 69 over 64 over 9, take square root. 64 is a squared, take square root, it's 8. 9 is 3 squared, take square root is 3. A over 3, got 2.6666, repeating. Round it to 1 decimal digits. To the right, 1 digit is 6. Greater than 5, round up, get 2.7. So variance is 7.1. Take square root is 2.7. There's another way to do. Another way, it's because this way, this formula, you have to each time minus mean, then square. Each time minus mean, then square. There's another formula. The formula is variance square equal summation x square over n minus mean square. You can use this formula to do. Because this one you just minus mean one time. This one each time have to minus mean. You have to minus mean 9 times. It's very complicated. So this one is going to be n is 9. And you do each number square first. 3 square, add. Next number is 5 square, add. 6 square, add until the last one, 12 square, then divided by 9. Then you do minus mean. Mean is, we figure out over here is 69 over 9. Square it. Use calculator, you will get the answer. Same answer is also 64 over 9. Same answer will be same answer. This is an alternate formula to do. You can use this formula to do. It's the same answer. This one you just minus mean one time. But this one you have to minus mean and put the parentheses square 9 times. That's take a longer time to calculate. But use this formula. It's a faster way to do. So we are learning. So far we learned the mean, variance, and the standard deviation formula. This variance have an alternate formula. It's a shortcut formula is variance square equals summation of x square over n minus mean square. Alternate formula. Next one we are going to learn is write the 5-number summary. 5-number summary. What is a 5-number summary? And construct a box plot. Now, what is a box plot? 5-number summary. So first of all, we list out those data. 3, 5, 6, 7, 8, 8, 9, 11, 12. Those 9 scores, 9 data. And the smallest one we call minimum. Minimum is 3. The largest one is 12. That's called maximum. Then 3 add and 1, 2, 3, 4, 5 is median. 1, 2, 3, 4, 5. From left, the 5th one. From right, the count, the 5th one. This is a median. Median we call second quartile, Q2, second quartile. And from second quartile, you separate this, the lower half. This is the lower half part. And those 4 numbers we call upper half part. From this median, you separate into lower half part, and the upper half part. In lower half part has 4 numbers, and you find the median also. 1, 2, 1, 2. There's 2 middle number. You add together. 5 add 6 is 11 divided by 2 is 5.5. we call first quartile. So between 5 and 6 is a 5.5, is the first quartile. On upper part have 4 numbers, also count 1, 2. 1, 2 from right, 1, 2. So there's 2 middle numbers. And the 2 middle numbers, 9 and 11, add together is 20 divided by 2, get 10. So it's right in between 9 and 11 is 10. We call third quartile. And why we call quartile? Because we partition into 4 quarters. This 1 quarter, this second quarter, then this third quarter, and this 4 quarter. So you have 1, 2, 3, 4, 4 quarters. You have 4 quarters. So this is a minimum, this first quartile. This is a second quartile. This is third quartile, and the maximum. And that's what we call 5 number summary. What's the 5 number? Minimum, first quartile, second quartile, third quartile, maximum. Total 1, 2, 3, 4, 5. So this we call 5 number summary. Then draw box plot. How to draw box plot? First of all, we have to use ruler. Draw this. We use the ruler to draw a line, to draw the ruler. On this line, you have to be equal, counted equally, like this 1, 2, 3, 4, 5, equal, 6, 7, 8, equally, equal lengths, 9, 10, 11, 12, 13, 14. So here is from 3 to 12. From 3 to 12. So this is enough. You can mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then maximum, minimum, maximum. Minimum is 3. Maximum is 12. So above this 3, you put a dot. Above this 3, you put a dot. Above this 12, you put a dot. Connect. This is a range from 3 to 12. From 3 to 12, this range. Then first quartile is 5.5. Between 5 and 6 is 5.5. Above 5.5, put a dot. And then second quartile is 8. Above the 8, put a dot. Then third quartile is 10. Above the 10, put a dot. On the first quartile, draw a bar. Second quartile, draw a bar. Third quartile, draw a bar. And connect those bars. Draw a box. And this we call box plot. Box plot. So here is this 5 number summary. 5 number is the minimum, first quartile, second quartile, third quartile, and the maximum. Total 5 number. 1, 2, 3, 4, 5. That's 5 numbers. And this, first of all, you need to draw the ruler. Then you can above that ruler and plot those 5 numbers summary. 5 numbers: minimum, first quartile, second quartile, third quartile, and the maximum. And those align. And then draw a box. That's what we call box plot. Then next one, second, the third question. Third question. Suppose a data set has a mean of 80. That means mean is 80. This is mu. Mu, it's 80. And the standard deviation is 2. So sigma is 2. According Chebyshev theory. What is the Chebyshev theory? According Chebyshev theory, we do following A and B. What is the Chebyshev theory? Here is the proportion of values from the data set that will fall within K standard deviation of the mean will be at least 1 minus 1 over K squared. Here K is greater than 1. Now this formula, K represents number of standard deviation. 1 minus 1 over K squared is the probability. The set of the data fall within, like this is a normal distribution. The mean is mu. And the standard deviation, 1 standard deviation, 2 standard deviation above the mean. K standard deviation above mean. K, if like K is 2, that's 2 standard deviation. Mean is here. This is 2 standard deviation. Sigma, 2 standard deviation. Mean add 2 standard deviation. This is a mean minus 2 standard deviation. If K is 2, then the area, the probability under this falling 2 standard deviation above the mean is 1 minus 1 over 2 squared. Is 1 minus 1 over 4. Is 3 over 4. Is 75%. That's Chebyshev theories. Means the proportion means the probability. The probability of values from the data set that will fall within K standard deviation of the mean will be at least 1 minus 1 over K squared. K is a number greater than 1. This is Chebyshev theory. So according to this, A ask you, what is the minimum percentage? At least. So it's minimum. What is the minimum percentage of the data values between 75 and 85? Given mean it's 80. Standard deviation is 2. So first of all, you have to figure out what is the K. What is K? Figure out the K. How to figure out the K? It's a standard deviation. You can use this one. mean minus k times standard deviation is like this, mean minus 2 times standard deviation, k we are looking for, equal minimum is from 75. So the mean is 80 minus k times standard deviation is 2 equals 75. Figure out the k. So you both sides minus 75. You move 75 over 80 minus 75. Move this 2k over. Change the sign, get 2k. And 80 minus 75 is 5 equal 2k. Divided by 2 both sides. Get k equal 5 over 2. So it's 2.5. 5 divided by 2 is 2.5%. 2.5 standard deviation below the mean. So this 75 is mean minus k times s. Mean is sample mean. This x bar represented sample mean. Sample mean. So I have to use sample mean. It's not population mean. This 80 is a sample mean, x bar. This 2 is s, standard deviation, sample standard deviation. Population use mu, mean use mu. Sample use x bar, average. And population standard deviation use sigma. Sample we use s. So this from mean minus how many standard deviation minus k times s is 75. From mean add k times standard deviation is 85. So you can use either this one or use this one to figure out the k. So it's the same answer. You got k equal 5 over 2. Then plug into the formula of Chebyshev theory. K use 5 over 2. So you get 1 minus 1 over 5 over 2 square. 5 over 2 is 5 square is 25. 2 square is 4. And 1 over, you need to reciprocal, become 4 over 25. Subtraction. 1 is 25 over 25. It's 1 minus 4 over 25. So 25 minus 4 is 21 over 25. And change to percent. Here 25 you times 4, you got 100. So 21 times 4 is 84. 25 times 4 is 100. So answer is 84%. So this area, if k is 5 over 2, then under the curve, falling 2.5, 5 over 2 is 2.5 standard deviation of the mean will be at least 84%. So the minimum percentage of data value between 75 and 85 is 84%. Next one. What is the minimum percentage of data values between 74 and 86? So you let 74 equal x bar, mean minus ks. Solve for k. Mean is 80 minus k times standard deviation is 2 equals 74. Move over, change the sign, get 2k. 74 move to the left, change the sign, become minus 74. 80 minus 74 is 6 equal 2k. Divided by 2 both sides. So get k equals 3. So it's a 3 standard deviation above the mean. Ask you at least how many percentage of the data is between 74 and 86, which is 3 standard deviation from 74 to 86 data. It's going to be 3 standard deviation above the mean. Mean is 80. So in the case 3, plug in is 1 minus 1 over 3 squared. So it's 1 minus 1 over 9. 1 change denominator is 9. And 9 over 9 is 1 minus 1 over 9. So denominator is 9. 9 minus 1 is 8. So it's 8 over 9. 8 over 9 use calculator divided is 0.8888 repeating. And change to percent. Move this decimal number to the right 2 positions. Get 88.8888%. Attach percent sign. And round it to 2 decimal digits. And so 2 decimal digits to the right, 1 digit, 8, round up. So get 88.89, attach percent sign. That's Chebyshev theory. Formula 1 minus 1 over k squared. Question 4. Next question. The scores on an exam from a class of 10 students are listed below. Those are the scores from 10 students in the class. Ask you, what score corresponds to the 75th percentile? B, what score corresponds to the 80th percentile? C, what is the percentile rank of 78? 78. Percentile rank of 78. So, first of all, we have to order the data first. Order those data first. How to order the data? You can use, we call the Stanley plot to order the data. How to use Stanley plot to order the data. First of all, we draw a stem. We draw a stem. We write down the stem. Those are the data. You can look at those for the 10 digits. Here's 10, here's 8, here's 7, here's 8, 6, 7, the 10 digit, 9, 9, 9, 8. So it's started at 6 up to 10. So your stand is 6, 7, 8, 9, 10. Then we are going to this we call stem. Then we are going to write the leaf. Write the leaf. 100. So 100. Then 85. 85. 77. 77. 89. On 8th. Those are 80s. 89. Next, 64, those are 60s. 64 and 78. 78, those are 70s. 99, 99, those are 90s. 97, 97, 94, 87. And this is a stem. From 10 digits, those are the leaf from 1 digits. Then put them in order. So put them in order. We write down the stem. 6, 7, 8, 9, 10. 64. This already in order. 7, 8. Ascending order. This 5, 7, 9. Change to 5, 7, 9. This 4, 7, 9. 4, 7, 9. Then 100. Now it's in order. This we call stem leaf plot. Stem leaf. Then we write down the number 64, then 77, then 78, then 85, 87, 89, 94, 97, 99, then 100. Now sorted in ascending order. So first of all, we order the data like this. Over here, I put them over here. Let's order the data. Remember to order the data. After data ordered, then ask you what score corresponding to 75th percentile. 75th percentile. Now here has use this formula. The count C equal N. N is how many data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data. So N equal 10. N equal 10 times P over 100. P is here is the 75th percentile. So it's 75 over 100. You times it and get 7.5 decimal number.